train step equal to TF train gradient reset optimizer learning rate minimize loss merged equal to TF summary merge all with the TF session as sessions train writer TF summary file writer log directory graph TF get default graph saver TF train saver with open OS bath join log directory metadata DSV W as metadata write name /t class /name for kv in index to word map items metadata write configure projector config embedding configure embeddings add embedding tensor name embeddings name link this tensor to its metadata file example labels embedding metadata bath OS bath join log directory metadata.tsv projector visualize embedding train writer configure TF global variables initialize run for step in range 1000 x batch y batch get skip grab batch size summary says run merged train step paid dictionary train inputs x batch train labels y batch train writer add summary step if step 100% is 0 save says OS bath join log directory WTV model checkpoint step last value session run last feed dictionary train inputs x batch train labels y batch print last at step last value normalize embedding before using normalize equal to TF square root TF reduce sum TF square embeddings keep dimensions true normalized embeddings embedding norm normalized embedding matrix says run normalized embeddings reference word normalized embeddings matrix word to index map 1 cosine distincts node dot normalized embedding matrix reference word ff equal to np argument sort cosine minus 1 1 to 1 10 colon 10 for f in ff print index word map f second print cosine districts of f output the above code generates following output loss at 0 100 200 300 400 500 up to 900 to 2.54086 embedding file 105 calling reduce sum tensor python or smart ops with the keep dimensions typicated and will remove further version instructor for updating keep dimensions depreciate use keep instead 9 7 5 up to 2 then next chapter TensorFlow single layer perceptron For understanding single layer perceptron, it is important to understand artificial neural networks. Artificial neural networks is the information processing system, the mechanism of which is inspired with the functionality of biological neural circuits. An artificial neural network possesses many processing units connected to each other. Following is the schematic representation of artificial neural network. Input 1, input 2, input 3, input 4, input 5. Input units. These are our input units. Hidden units, output units, hidden units, output 1, output 2, output units. The diagram shows that the hidden units communicate with the external layer, while the input and output units communicate only through the hidden layer. Hidden layer communicate through hidden layer. That is hidden layer. Input units connect hidden layer. This is the hidden layer. The pattern of connection with the nodes, the total number of layers and the level of nodes between inputs and outputs with the number of neurons per layer define the architecture of neural network. There are two types of architecture. These types of focus on functionality. Artificial neural network as follows: single layer perceptron, multi-layer perceptron. Single layer perceptron is the first proposed neural model created. The content of the local memory of the neuron consists of a vector of weights. The computation of a single layer perceptron is performed over the calculation of sum of the input vector, each with the value, multiplied by corresponding element of vector of the weights. The value which is displayed in the output will be the input of activation function x1, x2, up to xn. Input sum here. These are input. Input is sum. Activation function. Then output. That is target. We can say target. Target. Let us focus on the implementation of single layer perceptron for an image classification problem using TensorFlow. The best example to illustrate the single layer perceptron is through representation of logistic regression. Logistic regression. Sigmoid function. Now let us consider the following basic steps of training logistic regression. The weights are initialized with the random values at the beginning of the training. For each element of the training set, the error is calculated with the difference between desired output and the actual output. The error calculated is used to adjust weights. The process is repeated until the error made on the entire training set is not less than specified threshold, until the maximum number of iterations is reached. The complete code for evaluation of logistic regression is mentioned below. Import MNST data from TensorFlow, examples, tutorials, data, MNST input data. Data sets TMP data, one word, true. Import TensorFlow TF, import matploit library, yplot as plot, PLT. Parameters, learning rate 0.01, training focus 25, batch size, the display step, TF graph input, x equal to TF placeholder plot, y equal to TF placeholder float, none 784, none 10. MNIST data image shape 28 cross 28 784. 0 to 9 digits recognition is 10 classes. Create model, set model weights, this one 784 10. TF variable, TF zeros 10. Set model weights. Concept model, activation TF.nn narrator softmax TF.metmal x, w plus b softmax. Minimize error using cross entropy. Cross entropy y asterisk TF.log activation cost TF reduce mean TF reduce sum cross entropy reduction indices equal to 1. Optimizer TF train gradient descent optimizer learning rate minimizer cost plot settings average set epoch set. Initializing the variables, initialize TF initialize all variables. Launch the graph with the TF session as sets run initialize training cycle for a book in range train epochs average cost equal to 0 total batch initialize MNIST train number examples batch size loop over all batches for I in range total batch XS batch YS MNIST train next batch size fit training using batch data says run optimizer feed dict x batch XS y batch YS compute average loss average cost session run cost feed dictionary x batch XS y batch YS total batch divided by total batch display logs as bar epoch step if epoch display step 0 print epoch cost or not average cost average set append average cost epoch set append epoch plus 1 print training phase finish day plot epoch set average set label logistic regression training phase plot y label under cost plot x label under epoch plot legend plot show test model correct prediction TF equal of TF argmax activation 1 TF argmax YF1 calculate accuracy TF reduce mean TF cost correct prediction float print model accuracy equal x colon m1 ist test images y m1 ist test labels output the above code generates the following output here mentioning use TF global variable